Hi, this video is for page 8 of our probability packets. And we are looking at, again, just some practice with comparing the theoretical to the experimental probability. Again, this is page 8 in your packets. And one thing I want to mention before we get started is that these were true facts as of last year. And I would have updated them for this school year. I just obviously didn't have a chance just with everything that's going on. So if you are a soccer fan or a basketball fan, these facts would be true as of last year. And if you have no idea who Sergio Aguero is or Zion Williamson, then this wouldn't even make any difference to you anyways. But I did just want to throw that out there that this was technically the facts were from last year. So that said, Sergio Aguero, technically last year, was the top goal scorer in the EPL, the English Premier League. And for those of you who play soccer, you guys know that making a soccer goal in a game is actually a pretty big deal. And to be the top goal scorer is really impressive. And so when we look here to see what's the probability that he's just going to score in his next game, obviously that's kind of the same as basketball with the free throws, where you just look at the data and say, okay, that's the percent shooter that he is. So here in this situation, you can see I've got the makes, the 161 out of the 377. And let me just get a pen here. Sorry about that. So we've got the makes here out of the total attempts. And when you divide that in your calculator, that's the 0.427. And that's how we get that he's a 42.7% shooter. Okay. So that's the percentage that he's going to make a goal in the next game. Now, how does this compare to theoretical probability? Now, theoretically, we know what we would be just predicting. That's the same as a free throw. Like you're either going to make it or you're missing it. So like think about a soccer game, he could either score or not score. So theoretically it's 50-50. Now notice that even the top goal scorer is less than what we would have thought, which again just really kind of goes to show how tough scoring a goal is in a soccer game. And you guys know that. I mean, think about all those soccer games where the score is like 1-0, 1-0. So there's not a whole lot of scoring going on in soccer because it is a very, very difficult task. And this here kind of goes to prove that. All right. So that was some soccer. Now let's talk some basketball. So some of you might know in the NBA, Zion Williamson at this point is in the NBA. He plays for the New Orleans Pelicans. And when he was in college playing for Duke, he was the #1 player in the country. And let's take a look here at his free throw percentage. So far at that point in the season, he had made 123 out of 188 of his free throws. Now, what we can do here is we can kind of work down and say, all right, well, let's say we're just going to think about possibly one game. Maybe in like one game, in the next game here, he's going to get to shoot 6 free throws. So we might want to say, okay, let's predict how many he'd make if he went to the line and got to shoot 6 free throws. So here, we're just going to cross multiply 123 times the 6, and that's where I get 738. And now I'm going to divide it by the 188. Now you do get a decimal when we do this, and it's 3.9. So the whole entire point here, y'all, is that we'd expect Zion to make about 4 of those free throws. If he's going to go to the line and shoot 6 free throws, we expect him to make about 4. That's kind of the whole entire point here. Now, another thing we can consider is theoretically what we would have thought. Theoretically, everybody has a 50%. We've talked about that. So we can also compare that if he went to the line 6 times or was shooting 6 free throws, theoretically, we'd expect him to make 3 of those 6. And so theoretically is 3 out of 6. But based on the data, we expect him to make 4 out of 6. So his data says that he's a better than expected free throw shooter. All right, moving down the line here. So I am a huge college basketball fan, in case you guys can't tell. And I think I keep talking about like the NCAA tournament with March Madness. And I've shown you guys a picture of this before, but I just wanted to remind you, here's a picture of something called a bracket. This is the bracket. And here, when you add up all of these teams, here, this is 32. And over here, this is another, oh wait, sorry, this is 34. It's 34. And then 34 over here. So it starts out with 68 teams. We have 68 teams total that compete in the tournament. All right. Now the idea here is that, and you can kind of see a little bit, the picture's a little fuzzy, but you can kind of see here, there's like a small number 1 next to this. So going into the tournament, You've got a bunch of number 1 seeds, like here, this past year, Gonzaga was a number 1, Michigan was a number 1. Let's see over here. This was Illinois was number 1, and then Baylor was number 1. So when I say a number 1 seed, I'm talking about like the best teams in the tournament, all right? So back to our problem. In the NCAA tournament, there are 68 teams which compete to be the best in college basketball. Now, in the past 34 seasons of the tournament, the number 1 seed that I had just highlighted, one of those teams has won the tournament 21 times, all right? So going into the tournament, being one of these number 1 seed teams, it looks like 21 times one of these teams has won the tournament, all right? So you want to be one of these yellow teams going into it because there's a good chance you're going to win the tournament. And how do I know this? Well, we just say 21 times out of the 34 seasons. That means that 61.8% of the time we have a number 1 seed winning. So going into this, obviously each team theoretically has a 1 out of 68 chance. They're 1 out of the 68 teams. But when we use the data, we can see that actually these number 1 seeds have a way better than 1 out of 68 chance, a way better percentage of winning. So going into the tournament, ideally, you'd get a number 1 seed, and that means you have a pretty good chance of winning the tournament. All right, and now we're down to our last question. This should look pretty familiar, y'all. So for number 4, we have seen this setup before in your independent practice. So remember, James is flipping the coin 40 times here. You just add them up. And what's the experimental probability? So just straight up the results that it's going to land on tails. So that's the 17 out of 40. So even though we would expect half the time it to be a 20 and 20, it looks like it landed on tails less than what we expected here, less than what we expected. Theoretically, again, 20 and 20, 50-50. And so here we can see that's less than expected. All right, that takes care of the video here. There is a video check Google form for this, y'all. There is a video check Google form for this. After you submit the video check, you are going to be looking at pages 9 and then page 10. And this page right here, there's also going to be a Google form for you to submit those responses. All right, thanks for watching the video. Have a good day.